Hello everyone, this is Kalpana here. In this video, we're going to solve a problem using the method of undetermined coefficients. So let's get going. Problem. Solve d square y by dx square plus 3 into dy by dx minus 10y equal to 6 e power 4x using the method of undetermined coefficients. We are given a differential equation d square y by dx square plus 3 into dy by dx minus 10y equal to 6 e power 4x, right? Consider as equation 1 or let it be. We can write this as y double dash plus 3y dash minus 10y equal to 6 e power 4x, or d square y plus 3dy minus 10y equal to 6 e power 4x, right? Or d square plus 3d minus 10 into y equal to 6 e power 4x, which is in operator form. Say f of d into y equal to q of x, where f of d equal to d square minus 3d plus 10, minus 10, and q of x equal to 6 e power 4x, right? Where f of d equal to d square plus 3d minus 10 and q of x equal to 6 e power 4x, right? So we can write the given differential equation as y double dash plus 3y dash minus 10y equal to 6 e power 4x, or d square plus 3d minus 10 into y equal to 6 e power 4x, where f of d equal to d square plus 3d minus 10 and q of x equal to 6 e power 4x, right? Now we'll find the general solution to the given equation, which is given by y equal to yc plus yp, where yc is a complementary function, yp is a particular integral. We'll find yc using the auxiliary equation and yp using, okay, we'll see yp later. Fine. Now let's find yc using the auxiliary equation. Well, the auxiliary equation is f of m equal to 0, where f of m equal to, we have f of d square plus 3d minus 10, right? Let's replace the differential operator d by m, so that we'll get f of m equal to m square plus 3m minus 10. Then the auxiliary equation becomes m square plus 3m minus 10 equal to 0, right? Now we need to find roots to this equation. Okay, so we'll split this 3m as plus 5m minus 2m. Take m common from the first two terms and minus 2 common from the next two terms. Now take m plus 5 common from these two terms. We'll get m plus 5 into m minus 2 equal to 0. Now we equate each factor to 0. When m plus 5 equal to 0, m equal to minus 5. When m minus 2 equal to 0, m equal to 2. Therefore the roots are m equal to minus 5 and 2. Therefore m equal to minus 5 and 2. The roots are real and distinct. Well, using this roots, we'll find yc. Suppose we have real and distinct roots, say m1 and m2, then yc looks like yc equal to one constant into e power 1 root into x plus another constant into another root, e power another root into x, right? Now let's find complementary function using this formula. yc equal to c1 e power 1 root into x plus another constant, say c2 into e power and the root into x, which gives us c1 e power minus 5x plus c2 e power 2x. Therefore, yc equal to c1 e power minus 5x plus c2 e power 2x, right? Now, also we have q of x equal to 6 e power 4x, right? Now, observe the terms in q of x and yc, just compare q of x and yc, okay? The terms of q of x and the terms of yc. Here you are having, you need to observe the functions of x, not the coefficients, okay? Here you are having e power minus 5x, e power minus 2x and e power 4x. So you don't have any common terms in these two, right? Therefore, from this we can say that q of x has no common term with yc. Therefore, yp will be the linear combination of q of x and all its linearly independent derivatives. When q of x equal to some constant into e power some px, say, then yp will be a naught into e power the px. Okay, this is a formula. Okay, now we'll not just use the formula directly. We'll find the derivatives of q of x and later we'll decide yp. Okay, this is a formula. You can just apply it directly, but if in case you forgot it, suppose you forgot the formula, then you'll find trouble to find yp in exams, right? So for that purpose, we'll see how to find yp using q of x by comparing with yc. Let's see. Well, we have compared the terms of yc and q of x and we came to know that no term is common. Now, take q of x, just take the function of x, okay? Neglecting the constant coefficient 6. If q of x equal to e power 4x, then find its derivative. q dash of x is 4 e power 4x and find its derivative. Find the derivative of q dash of x. 4 is 16 e power 4x and q triple dash of x is 16 4 64 e power 4x. So, while finding the derivatives, e power 4 gets repeated, right? See, q of x has e power 4x and q dash of x has e power 4x. Again, its derivative for e power 4x, it just continues, right? So, now write all the functions of x in q of x and its derivatives in set form. Okay, you have q of x e power 4x and its derivatives also having e power 4x, and we don't have any other function, right? Any other functions of x except e power 4x. We don't have any other functions of x. So we'll write yp using this e power 4x, or using this set we can say, right? As I said earlier, we have to neglect the constant coefficients 4, 16, 64, and here you're having, where is that, 6. Just neglect it, okay? Neglect it. It's not necessary to have. Okay, you'll just have a constant in front of every function. Just neglect it. Now observe, q of x and all its derivatives, it just has e power 4x and nothing else, right? Now using this set, we'll find yp. Yp equal to e power 4x with undetermined coefficient, say a. Okay, this is the formula. See, you got the same thing, right? This is the formula where you have a naught and here you're having p, where p equal to 4. This is easy, right? Instead of remembering the formula, you can just find yp using q of x and its derivatives. Well, now we are having yp. We have chosen yp such that it satisfies the given equation. Okay, now if it satisfies the given equation, you'll get yp double dash plus 3yp dash. I mean, you can write the equation as in terms of yp, right? So here you're having yp, yp dash and yp double dash, right? We have only yp. We need to find yp dash and yp double dash now. Let's find yp dash equal to a into derivative of e power 4x is 4 e power 4x, which gives us 4a e power 4x, right? Now find yp double dash. This is equals to 4a into derivative of e power 4 is 4x is 4 into e power 4x, which gives us 4 4s are 16 a e power 4x. Now we got yp, yp dash and yp double dash. Let's substitute a, yp, yp dash and yp double dash in this equation, because yp satisfies the given equation, okay? Because it is a solution. It is also a solution, right? So it satisfies the given differential equation, so that the given differential equation can be written as yp double dash plus 3yp dash minus 10yp equal to 6 e power 4x. We have yp equal to a e power 4x, yp dash equal to 4a e power 4x, and yp double dash equal to 16a e power 4x, right? We can write 1 as, that is the given equation, 1 as yp double dash plus 3yp dash minus 10yp equal to 6 e power 4x, since we have chosen yp such that it satisfies the given equation, because yp is also a solution to equation 1, so it satisfies equation 1, so we can write the given equation in terms of yp. Okay, no confusion. Now substitute the values of yp double dash, yp dash and yp here. You'll get 16a e power 4x plus 3 times yp dash 4a e power 4x minus 10 times yp a e power 4x equal to 6 e power 4x, which gives us 16a e power 4x plus 3 4s are 12a e power 4x minus 10a e power 4x equal to 6 e power 4x. Now simplify it. 16, okay, let it be 12a e power 4x minus 10a e power 4x is 2a e power 4x. 16a e power 4x plus 2a e power 4x is 18a e power 4x. From this you'll get 18a equal to 6, which gives us a equal to 6 by 18, right? 6 1s are 6 3s are. Therefore, a equal to 1 by 3. We have yp equal to a e power 4x. So substitute the value of a, since a equal to 1 by 3. We'll get yp equal to 1 by 3 into e power 4x, right? Therefore, yp equal to 1 by 3 into e power 4x. So we got yp and yc. Let's now write the general solution using y equal to yc plus yp. Therefore, the general solution is given by y equal to yc plus yp, then y equal to yc c1 e power minus 5x plus c2 e power 2x, and yp is 1 by 3 e power 4x. Therefore, y equal to c1 e power minus 5x plus c2 e power 2x plus 1 by 3 into e power 4x is the required solution. Okay, we got yp equal to 1 by 3 into e power 4x. Fine. Now let's verify yp. We can verify yp using 1 by f of d into q of x, where f of d is d square plus 3d minus 10 into q of x is 6 e power 4x. We can write this as 6 into 1 by d square plus 3d minus 1 into e power 4x. See, this is of 1 by f of d into e power ax form, right? Just compare these two, then for a equal to 4, we'll just find f of 4. If f of d is d square plus 3d minus 1, then find f of 4. Just replace d by 4, you'll get 4 square plus 3 into 4 minus 1, which gives us 4 4 is 16 plus 3 4 is 12 minus 1, 28 minus 1 equal to 27, right? So you have f of d minus 10, it's not 1, sorry, which gives us 28 minus 10, 18, which is non-zero. Since f of 4 is non-zero, so just replace d by 4. You'll get 4 square plus 3d minus 10, 3 into 4, into e power 4x, which gives us 6 into 1 by 4 square 16 plus 12 minus 10 is 18 e power 4x, 6 1s are 6 3s are, which gives us 1 by 3 e power 4x, which is our required yp, right? So which shows that our yp is correct. Fine, this completes the problem. Well, we have discussed a problem using the method of undetermined coefficients in this video. I hope you'll understand. We'll see you in the next video. Until then, bye bye.